The complex number W is defined by this fraction. Without using a calculator, show that W equals 2 plus 4 iota. Okay. Let's start with expanding the denominator. Let's do that here. It's going to be 2 minus iota whole square, which gives a squared, minus 2ab plus b squared, which is -1. So 4 minus 4 iota minus 1, which gives 3 minus 4 iota. So that's the denominator. Show all the working on the side. All right, now we're going to rationalize it. 22 plus 4 iota over 3 minus 4 iota into 3 plus 4 iota upon 3 plus 4 iota. Okay, rationalize this. In the denominator, we're going to use the identity a square minus b square. Let's do that here as well. A squared minus b squared, which gives 9 minus 16, since iota square is also -1, which gives us 25. So 25 in the denominator. And for the numerator, it's going to be 66 plus 88 iota plus 12 iota and plus 16 iota squared, which is -16. So this gives 50 plus 100 iota. Write that here. Now divide the denominator separately. So we get 2 plus 4 iota as our final answer. And that is what W is. Okay, next part. Part 2. It is given that P is a real number such that pi by 4 is less than or equals to argument of W plus P and is less than or equals to 3 pi by 4. Find the set of possible values of P. Okay, for that, what we'll do first is sketch an argument which is between pi by 4 and 3 pi by 4. Argument means angle from the origin. So 3 pi by 4 would be an angle over here. I'm sorry, pi by 4. Pi by 4 is exactly 45 degrees. So it needs to pass exactly in between. And 3 pi by 4 is 3 into 180 divided by 4. That is 135. And if you do 180 minus 135, that's also 45. So that means 135 is going to be an angle passing through the middle of this, because this is going to be 45 in degrees as well, and this will be 45 in degrees as well. Okay, so this is the argument from the origin, and W is already known. W is 2 plus 4 iota. So let's say 1, 2, and 1, 2, 3, 4. This is where the point is. All right, so this point clearly has an argument greater than pi by 4 and less than 3 pi by 4. Its own argument would be this. Join this from origin, and whatever this angle is the argument of the point. But we need to add a real number to it. It says add P to it. P is a real number. That means when we add real number, this can move in this direction or this direction. If you add something to it, it's going to move leftwards. If you subtract something to it, if you add something to it, it's going to move rightwards. Otherwise, it's going to move leftwards. All right. But it's allowed to only stay between on this line. It can't go out of it, because then the angles would go beyond the given domain. So now what is P? What can we add to it and what can be subtracted to it such that the complex number lies within this orange line? Okay, first of all, this was 4. So on this line, we'll have a 4 here, because this line, if you remember, this angle passes exactly in the mid from the middle of x and y axis because it's 45. So it's gonna 45 degrees. So it's gonna pass through 4 comma 4. And over here, if this is 4, this would be negative 4. All right. So that means we can add, this is already at 2. So at max, we can add 2 to it. So then it will fall on this border. So this, you can give a +2 to it maximum. And in the opposite direction, this is 2 units and then this is another 4 units. So it's a 6 unit. So you can subtract 6 units from it and it will still lie on the orange line. If you subtract any more than 6 units, then it's going to fall out of the line. So that means P lies between -6 less than or equals to P less than or equals to 2. That's it. This is your working and this is your final answer. Part 3, the complex conjugate of W is W conjugate, W steric. The complex number W and W steric are represented in an Argand diagram by the points S and T respectively. Let's draw that. Okay. Um, all right. So the first point is W, which is 2 plus 4 iota. So 1, 2, 1, 2, 3, 4. Somewhere over here, this would be S. And then its conjugate would be 2 minus 4 iota. This is going to be 2 minus 4 iota. So that's going to be here 1, 2, I need to be careful about the scaling. 1, 2, 3, 4. Roughly over here, this is going to be T. This is 2, this is 4, this is -4. And since it's an Eigen diagram, clearly mark the real part X, imaginary part iota Y. Okay. Next it says, uh, find in the form of modulus of z minus a is equals to k, the equation of a circle which passes through S, T, and the origin. All right, so let's make a circle pass through origin S and T. It's going to be something like this. And we need to find equation of the circle. That means we need its center and we need its radius. Okay, so now since this is S, which is 2 comma 4, and that is T, which is 2 comma -4. We know that the center of this circle is going to lie somewhere on the x-axis because this is a very symmetrical, these are two very symmetrical points and the middle of the circle will be exactly in the middle of these 2 points. So hence the center would lie somewhere on the x-axis. Okay, now how do we find the center? How do we find the radius? Let's use a bit of trigonometry. Let's apply Pythagoras to get this length. This length is 2 here and sorry, that's 4 and this is 2. So apply Pythagoras on 4 and 2. So 4 square plus 2 square under root, it's 2 under root 5. So this is 2 under root 5. All right. Now if I join it with the other end, since the blue line is the diameter, we know from O levels angle subtended from a diameter or angle in a semicircle is 90 degrees. All right. I would need another angle on this figure. I could find this angle because this is, like we said, 4. And I just found 2 under root 2. In fact, I didn't even need 2 under root 2 because this is going to be 2 units and that is 4 units. So we can apply trigonometry and find this angle. This is going to be tan theta is equals to opposite over adjacent. This is going to be 90 degrees too. Okay, so tan inverse 4 over 2 gives us 1.10 something. Yeah. So theta comes out to be 1.107147. Okay. Next, I can use the bigger right angle triangle and find the diameter, which is the hypotenuse. So I have 2 under root 2 as well. Now that will come in handy. So I can use cos now. Cos 1.107148 is equals to opposite, which is, no, sorry, adjacent over hypotenuse. So 2 under root 5 over d for diameter. So diameter will be equals to 2 under root 5 divided by cos answer. It's giving me exactly 10. So if diameter is 10, then the radius is going to be 5, and then the center will be 5 units ahead, 5 comma 0, or 5 plus 0 iota. Okay, so now we can write it as C minus 5. You flip the sign, minus 0 iota is equals to, radius is also 5. So our answer would be Z minus 5 equals 5.